This video shows you how to use the RSP TCP server for remote SDRplay operation. We'll be downloading a Raspberry Pi 3 SD card image. We'll then use that SD card to set up a remote antenna, an RSP-1A, and a Raspberry Pi 3 running the TCP server software, and we'll make that server accessible over the internet. Back at base, we will install the ExtIO plugin on a Windows laptop PC running HDSDR, and we will demonstrate HDSDR accessing the remote SDRplay with full RSP resolution. For the remote location, we've got a nice broadband antenna that covers all of MF up through HF into low VHF. We've got SDRplay RSP 1A. We've got a Raspberry Pi 3 Model B. And for this demo, we're actually plugging in a keyboard, mouse and monitor. And we also have the luxury of power and a good internet connection. Here's where to get the SD card image. Go to www.sdrplay.com, go to the download section, and under Raspberry Pi you'll see there's a clickable download link called RPI 3 image. So click on that. Rather than taking you to an immediate download, it will refer you to an information page, which is worth reading because it shows the full extent of the software available on the Raspberry Pi image, of which the server software is just one new and important part. Now scroll down to the section called Instructions, where you will see a clickable link to download the image. Once you've downloaded the image, make sure you know where the file is. Usually it's some kind of default downloads folder. Take your SD microcard. We're using a 16GB card here. Put it in the caddy or adapter if needed to fit into the SD slot on the Windows PC. So we'll need some software specifically to burn the SD card image, and we recommend the use of Berliner Etcher. If you go to www.berliner.io/etcher and download the software. Once it's installed, it's a fairly straightforward process to first of all select the image from wherever you saved it, the downloads folder for example. Make doubly sure that you're selecting the correct drive for the SD card. You can see here it's got 15.93 GB, so that sounds about right for a 16GB card. It's nice and empty and ready to use, and then click on Flash. So this process does take quite a few minutes, so be patient, and it does seems to take a while to actually get going, but once it does, maybe 10 or 15 minutes before it's finally gone through the whole process and done its checks. But it should go quite smoothly, and at the end you should get the green check sign saying Flash complete. Now it's time to remove the SD card from the caddy and pop it into the Raspberry Pi. So now it's time to connect. In this example, we are using a keyboard and mouse, although in theory this can be used as in a headless situation where you're actually, once it's sort of set up, you can remote in and do most of this process. And certainly repeated access doesn't require visiting the site all the time. But for getting going, just we've used a keyboard and a mouse. We've got the internet connected. We've got the RSP-1A connected. We're using an HDMI monitor, and that's all the wires that you see going into the Raspberry Pi. And the USB cable from the Raspberry Pi goes to the RSP1A, and the HF antenna connected via its coax to the SMA connector on the RSP1A. As soon as it powers up, you'll get a warning that the default condition is that remote access is enabled, SSH, and it just has a default password, and that hasn't been changed. So this is a security risk, so we do advise logging in as the Pi user and running the Pi configuration just to set a new password. So once you've said OK to that, you'll see that you get a welcome message, welcome to the Raspberry Pi EasyPlay menu. So click on EasyPlay, and then you see the directory or the listing of all the different software that's available, and there's other videos that go through some of that. But today specifically we're interested in item number 9, which is the RSP TCP server. So click on that, and that should take you to a screen that says that it's detected the RSP. In this case it's RSP1A, and it's listening. So in theory we're all ready for remote listening, except first we need to open up your internet router to allow access from the internet. Now, a lot of this stuff will be very specific to your particular way that you connect to the internet from your remote location. Here in the UK, this is a fairly domestic type setup we're demonstrating here, using a BT home hub, an ADSL connection. But there's really two things we have to do. First of all, we've got to make the Raspberry Pi visible to the router, and there's a few little commands that are listed here that you need to type in. The first one is sudo sudo apt install UFW, and UFW stands for uncomplicated firewall, and this will just allow you to then open up specific ports for the remote activities that are necessary here. And then it's basically an allow command for any port that you want to open up. And at this point you're opening up the Raspberry Pi, so you can be seen in it by the rest of the LAN network. So this is the first step. So we need to allow ports 1, 2, 3, 4, which is the Raspberry Pi TCP interface. We need to allow 22 if you're going to want to use this as a headless device, and access using the SSH secure shell interface. And if you are going to be using the ADSB web interface, you can also open up and allow port 80. So you set the ports that you need to open up on the Raspberry Pi, and then you type sudo UFW enable, and then do a reboot as shown here. So that gets the Raspberry Pi to the point where it can be seen across the network, or your local network. And the next step is to go to, if you have a typical sort of internet router, you need to go in and investigate the network to find the local IP address of where the Raspberry Pi is. And you can see on this example, I had to go into the router manager, which is on the local network, and type in passwords and so on to get into it. And then I found that my Raspberry Pi is on this local address, 192.168.1.182. Now we're going to go to the port forwarding section of the router controller, and we want to allow port forwarding to port 1234 for our Raspberry Pi server, which we already found out was on 192.168.1.182. So create a new rule, RSP TCP, I've called it, put in the local IP address where the Raspberry Pi is connected, and open up port 1234, the protocol being TCP. Make sure you save this and double check that that rule is active and running, and then will be visible to the internet. But before we drive off into the sunset to remotely access our remote radio, make sure you go onto whatsmyip.org or some similar lookup site to find out what your IP address is as far as the outside world is concerned, and it might be something like 88.191.85.149. Anyway, just make a note of it. Now we're going to take a look at what we have to do at the other location. We're using a Windows laptop PC and HDSDR SDR software in this example, and we'll show how to install the ExtIO plugin, which ensures that you have extended mode operation working for the server, giving you the full resolution of the RSP up to 14 bits. We're assuming that you've got HDSDR already installed. If not, you can get that software from www.hdsdr.de. Then go to www.sdrplay.com/downloads. And now on your PC, go to Downloads, Windows, and find ExtIO plugin TCP by scrolling down, and then download it. The compressed ExtIO DLL file will need extracting and putting into the same directory where the rest of your HDSDR software resides. So that's typically in the program files folder. I'm now just double checking that indeed inside the HDSDR directory there is a DLL file alongside the HDSDR application. Right, now this slide is quite important because you do have to do things in the right order here. First of all, launch HDSDR, but go ahead and hit the stop button because otherwise you can't modify the characteristics of the ExtIO file. So the default when it launches is to start, so just hit the stop. Then the second thing to do is find the ExtIO button, which should be in light blue. Click on that, and then you'll get the ExtIO dialog box, and it's just going to sit there mostly grayed out until we actually get some connectivity to our remote Raspberry Pi. First thing to do, or I guess it's the third thing to do here, is uncheck those two boxes which have a tick in them, auto reconnect and persistent connection. I have found if you leave those there, you can end up crashing and having to kill the task. So just get rid of those. You really don't need them at all for this application. Fourth, make sure you've done that before then overtyping what the IP address is that you wrote down earlier. In that example, I think we said 88.191.85.149, whatever it is. Type in that remote IP address followed by the colon 1234, which is basically saying, please, can I communicate with this device, which is the Raspberry Pi, on port 1234. And as you know from earlier, everything's sitting there waiting to hear from you. Finally, go back to the green button in the bottom left-hand corner and hit start to get it going. At this point, HDSDR should launch with remote access to the RSP and Raspberry Pi working. However, the gain will be set to absolute minimum and any of the RSP specific options won't be selected yet. The first thing to do is just make sure you've got the lowest possible sample rate until you can have growing confidence in how good your internet connection is. Second thing to do is untick the AGC box and slide the gain up to the midway point. From then on, the HDSDR software will be able to take control of the gain. Choose any RSP specific options, for example, which antenna port you need in the case of, say, an RSP2. So there we have it. Let's have a look at it in action. So band's not particularly good here, but just to demonstrate, here we are with HDSDR running. This is 80 meters, so 3.79 megahertz. And if I just stop it for a moment, open up the dialog box so you can see we're at 0.25 megasamples per second, so we have 250 kilohertz of spectrum visibility. I've turned on the broadcast notch filters of the DAB notch filter, and I've got the gain set pretty high. So just one more time to iterate. We've got the host IP port at the top here, which is accessing the remote server running on the Raspberry Pi.
The band is speaking at that time. This is Delta Florida 2 B Bravo, Oscar DS2BO, Denmark Florida 2 Blue Ocean. We need Johan EA3 AKP, and he will make it. It was amazing, Ivan, when I listened to him yesterday. You should have heard his signal on W6SDZ. It was just incredible, simply incredible. He was really booming over there, just amazing. This is Delta Fox 2 Blue Ocean with company.
So let's look back at what we've seen here. For the remote location setup, we first downloaded the Raspberry Pi SD card image and used that to set up our remote location with antenna, an RSP1A, the Raspberry Pi running the TCP server software. We made sure that the port 1234 was accessible from the internet. Then back at base, we installed the ExtIO plugin on a Windows laptop that was running HDSDR, and we demonstrated HDSDR accessing the remote RSP1A with full RSP resolution. We haven't covered here headless operation, although that's already enabled at the remote end with the configuration that we showed here. We didn't cover other server platforms like Windows and Mac. There are binaries available, so you can see the TCP server user guide. The URL is listed there, although you can find it in the downloads section of the SDRplay website under documentation. Scroll right down to the bottom. Many thanks for watching, and do check out all the other information that's available on our website www.sdrplay.com.